Okay, now let's start with number 2, part A. Dissect the heart of a sheep following the steps given in document C or D. I will attach a video of heart dissection on the YouTube channel also for you to see, because we can't do it in the lab. So, part B. Where are the tricuspid, bicuspid, and sigmoid valves located in the heart? Let's go back to the previous flip chart and let's see these white structures located here that are called the valves. Okay, these structures, teacher, are called valves. They are just like gates between, located in certain places. Let's start with the first valve. This is called the tricuspid valve. Where is it located? If we remember the names of these structures, it is located between the right auricle and the right ventricle. Okay, so the tricuspid valve is located between the right auricle and the right ventricle. Now let's see the bicuspid valve. The bicuspid valve is here. Look, it is here. Okay, this is the bicuspid valve. Where is it located? Let's also recall the names of these structures. It is located between the left auricle and the left ventricle. Okay, so the bicuspid valve is located between the left auricle and the left ventricle. They also want the sigmoid valve. Now, the sigmoid valves, teacher, are these valves right here. Okay, this is called the sigmoid valve, and this is also called the sigmoid valve. If we want also to recall the structures, it is located between the first sigmoid valve is located between the right ventricle and this vessel, which is the pulmonary artery, if you remember. While the second sigmoid valve, this sigmoid valve is located between the left ventricle, if you recall, and the aorta. Okay, so let's repeat. First of all, the tricuspid valve, this one, is located between the right auricle and the right ventricle, while the bicuspid valve is located between the left auricle and the left ventricle, while we have two sigmoid valves. The first one is located at the bottom of the pulmonary artery between the right ventricle and the pulmonary artery, while the other sigmoid valve is located at the bottom of the aorta, which is between the left ventricle and the aorta. Now, what can you notice about the wall of the ventricles? Let's see here this image, please. Look at the wall of the ventricle. We have, this is the right ventricle and this is the left ventricle. Notice the tricuspid and the bicuspid valves very clear, and these are the sigmoid valves, as we said. Let's look at the wall of the ventricle. The wall of the right ventricle appears to be thin, while the wall of the left ventricle appears to be thick. Now, if we want to explain this difference in thickness, let's look here first. We said that the right ventricle is connected to the pulmonary artery, and eventually, as we said in the beginning of the lesson, the pulmonary artery carries the blood to the lungs. And if we remember, the lungs are very close to the heart. So when the ventricle wants to push the blood to the lungs, it will not need to make a big effort. So it doesn't have to be, the muscle doesn't have to be very thick. It only has to have a thin muscle to perform this low level of effort or pressure. But if we look at the left ventricle, which is connected to the aorta, the left ventricle has to push blood to all the body organs, which are sometimes very far away from the heart, like the legs, for example, or the arms or the fingertips. So here the left ventricle has to perform a high pressure. Okay, it has to push the blood with a high force. So that's why the muscle of the left ventricle, or the wall of the left ventricle, has to be thick. Okay, so we see that the wall of the left ventricle is thicker than the wall of the right ventricle. Let's just give the answers. Number 2B, we say that the tricuspid valve is located between the right auricle and the right ventricle. The bicuspid valve is located between the left auricle and the left ventricle. The sigmoid valves are located between the left ventricle and the aorta, and between the right ventricle and the pulmonary artery. Remember to copy these notes on your copybook. Now, number 2C, the wall of the left ventricle is thicker than the wall of the right ventricle, as we saw in the image. Part 3, based on document E, formulate a hypothesis concerning the role of the sigmoid valves. Let's look back at the image. Imagine now, in order to answer this question, that these ventricles will contract and push the blood through the arteries. Look here, if the right ventricle pushes the blood through the pulmonary artery, what would happen if there was no valve? Of course, the blood will fall back down, right? The same thing will happen if the left ventricle pushes the blood to the aorta and there was no valve, the blood will fall back. So here we can notice that the valve works like a gate, it's like a door. When the blood is pushed through from the ventricle to the artery, this gate or this valve closes and prevents the back flow of the blood. The back flow means flowing to the back. So when the blood gets out into the arteries, the sigmoid valves will close after it and the blood cannot fall down back to the ventricle. The same thing, of course, for the tricuspid valve, because when the auricles push the blood into the ventricles, these valves will close, preventing the back flow of the blood. So here we can say, of course, we have to write first hypothesis. The sigmoid valve prevents the back flow. Back flow is a very important word here, of blood from the arteries to the ventricles. Okay, let's watch, in order to understand more what are valves, we will watch these two videos. First of all, we have here a short video about the valves. Okay. Here we see that the blood is pumping. Okay, you see how the auricles are pumping the blood down into the ventricles, and then the ventricles are pumping the blood out up into the arteries. Notice here how the tricuspid and bicuspid valves are opening and closing. Here we have this septum that separates between the right ventricle and the left ventricle. Okay, now the right auricle is pushing the blood into the right ventricle. We see here the tricuspid valve. It is called tri because it has 3 leaflets or cusps. Okay, and the left auricle is pushing the blood into the left ventricle. Also, it's called the bicuspid valve. It is made of 2 leaflets or cusps. It also resembles the hat of the bishop, so it's called mitral valve. Now, let's look more through these valves. So these are the tricuspid and the bicuspid valve. Okay, they are connected to the muscle of the heart by certain tendons, okay, and certain muscles. Now, they open and close in certain times to prevent the backflow of blood. Now, when the auricles push the blood to the ventricles, now the ventricles have to push the blood to the arteries. Here, between the ventricles and the arteries, we have the sigmoid valve. Look here at these valves. These are the tricuspid and the bicuspid and the sigmoid valves. Look how they open and close in a certain manner, okay, in a certain rhythm. So, look at the heart wall now, as we said about the wall of the right ventricle, okay. Of course, the auricles have a thin wall also. The right ventricle has a thin wall, but if we look at the wall of the left ventricle here, we can see that it is thicker than the right auricle.